Great. Nearly every researcher and research operations specialist in the UX field and many fields is asked, what is the best tool for the job? My name is Andy, and I'm a design operations program manager at JP Morgan Chase. I've worked in design operations for 3 years. And that's about the same time that I got involved with the research operations community. And one of my focus areas has been the discovery, like evaluation and onboarding of vendor tools. That got me involved in a special project with the community. And that's also how I met Pete, who's became an amazing partner bringing data and graph capabilities to this really cool project. Pete?
Yeah, thanks for that great introduction, Andy. Yeah, my name is Pete Tunkis. I am one of the lead data scientists at a software consulting firm based in Calgary, Alberta, Canada, called RCurve. And so I was introduced to the ReOps community through my spouse, who happened to be pretty involved and she's also happens to be a ResearchOps leader. So I've lived vicariously in this world for a little while. And when I learned about the Toolbox and what the ReOps community is doing in its mission, it was hard for me to not want to get involved. And what we're going to be talking about today was, to me, really the perfect opportunity to get involved in the community and also test out some things in Graph that I hadn't done before, and test out some things that I had. And yeah, it's been a pretty great journey. So yeah, without further ado, then hopefully you can see, there we go. So we're on the agenda then. So what we're going to do first is Andy's going to walk us through kind of like what the ReOps community is, its mission, and what the Toolbox Census is all about. And then we'll talk about our sort of value add, or the enhancement that we're working on and demonstrating for you today that works with the Toolbox Sentence to bring the usefulness and its usability just a little bit further into the awesome zone. But then we'll kind of talk about what tools we used in order to accomplish our goals for this demo, as well as for the utility of what we're demonstrating in general. And then I'll kind of walk us through a little bit of a demonstration in terms of the what and the how, as well as a couple of examples and like a live demonstration of what the tool and the enhancement actually is, what it looks like, and how we can visualize and understand it. Yeah, let's talk about the ReOps community. Andy.
Yes. So we all know about lots of ops: DevOps, design ops, business operations, name your ops. The thing is, research operations is no different. It's about supporting the work, scaling best practices. The research operations community itself is a global group of, call it 10,000, maybe 12,000 people who come together to discuss the operations of user research, design research, things like that. Through meeting these community members, I became involved in a project called the Toolbox. It's sponsored by the community, and it creates and maintains resources that allow people to find what tools are being used, like maybe what industry they're used in, by what size of team, and where research might be conducted in the world, or where in the world that research might be conducted on. So the Toolbox is a really fun challenge. We've talked to a lot of researchers, and we find ourselves doing a lot of common activities. They do tool audits, analysis, evaluations, justifications for budget, because this is a hot field and these are very expensive things. This is time consuming, and it can be a lot of really expensive business decisions get to be made. The community has a Slack group, and the community has so much amazing knowledge about this. Like, a lot of people are doing these same activities, and in our channels, a lot of valuable information often falls away into message history. So we can't help but think about how can we capture all that amazing knowledge. There is a vast landscape of tools and a super rapidly evolving domain of largely user experience. Our project identified 49 specific tasks, and we fit them into like 8 categories of tasks that, like, in particular, researchers and research operations professionals conduct on, a regular basis.
Mhm.
Yeah, I hope that provides a little good background.
Yeah. And so as Andy said, what the toolbox gives us is it gives us a much clearer way to explore the landscape of what UX research and design operations and the teams themselves are using and doing around the world, right? It's meant to be a census in that sense, if I may. Ha ha ha. However, right, after a point though, okay, so we've collected the data and all of this, but we just sometimes just got to kind of like take a breath. This is really exciting. We've released a really neat resource into the wild for our community members to make the most of. We just got to sit down and just take a moment, look at one another and say, what does this do for me? Right? Or really, instead of, a bit less, Nick Offerman-y, is really we can ask, well, what is the actual value for my team, right? Like I can have a sense of what all the tools are in the world and all this sort of thing, but what makes the most sense for my team? So let's take a look at the toolbox itself and what that actually looks like. Andy?
Yeah, just for background purposes, I grabbed a couple of screenshots, and what you see here is some visualization of some survey results that the toolbox provides. Something like 400 survey participants, and here you can see we've got a visualization of what industries they work in, and these results are currently filtered by some demographics, including, people who answered that they work in tech and finance industries, like me. That's where I work. So and then you see on the next slide, we've got, for example, one of the 48 use cases might be called something like collaborative brainstorming. This is like very commonly like a digital whiteboard where designers and researchers are generating lots of fresh ideas. And because there's over 400 tools, and I said like 38 use cases, it can be very helpful to be able to know what users like me might be more likely to use. Just for example, like up here at the top of the results are things like Figma and Mural, but those might not be available to me in a highly regulated industry like medical or finance or something like that. So I hope this gives an idea of like how we saw already so much potential in this data, but really quickly we lacked someone like with Pete's skills to even learn more from it.
Well, flattery gets you nowhere, sir. But we have a solution. We have a potential solution that we've been experimenting with and we put together because really, right, we've asked this question in a handful of different ways so far, certainly implicitly, I would say. But again, right, what's the best tool and what's the right tool for, let's say, we're wanting to do, concept testing or collaborative brainstorming. But for a team like mine, because I think it's critical, Andy, what you mentioned about like, are there like regulatory reasons why we might not be able to use, let's say for the sake of argument, why we can't use Mural or Figma or something, right? And what that means, right? I think a lot of folks in the ops world, or worlds, I should say, are familiar with this concern, right? If you're working or based in Europe or your clients are out there or so, right? Then oftentimes the software that you're building or developing is going to be subject to a very different regulatory framework than what we have or don't, depending on your point of view in the US or in Canada, right? So in those situations, right, just because Figma happens to be a very popular thing doesn't mean that like me being in Europe, again, for the sake of argument, I don't know why this would be the case, but for the sake of, right, I can't use Figma because if I do, like somebody is going to sue me into the ground or, like my company's going to get shut down or who knows, right? Like worst case of worst case. So we do need to have a clear confidence of what is the best for us. And so in my mind, the line was kind of drawn right away to a recommendation system, right? In other words, like the first thing that comes to mind when we hear about recommendation systems is sort of the Amazon or the Spotify, Netflix type of thing, where Amazon's is sort of a gold standard example in many ways, right? When you click on a product, you find something, and then towards the bottom it'll say, here are some items that are similar to the one that you're looking at, as well as here are some items that people bought in addition to this thing that you're looking at, right? So it's recommending that you purchase or select additional products on top of what you are already looking at right there. And for me, the same thing kind of applies, right? Because we're interested in knowing what the best tool is for a given use case. We know that there are research and design teams around the world who use these different tools for different use cases. And so if we bring all that together, in addition to better understanding of who is using those tools, then we can really kind of tailor our recommender system so that it's giving us the right kind of information that we need. But what does that actually mean, and what does that look like? And I'm just going to run through a quick review of what recommendation systems are, since I know that like recommender systems, are virtually ubiquitous, right? They're all over the place, but there are different flavors thereof, right? And so one example of a recommendation system that we might see out in the wild is so-called content-based. And all that is we can just kind of, if we can imagine, a product that has, let's say, 5 different features to it, and we have a possible user who might be interested in making use of that tool or not, right? But we want to see is it possible to match that tool up with that person? And so we see, based on that person's preferences, they match up with the characteristics or properties of the tool or the product. And so we just kind of do a dot product, right? And the more things match, the more likely it is that that tool or that product is going to get recommended to our user. The alternative side, which is really what we see most often with Amazons and Netflixes and all that sort of business, is collaborative systems. And for collaborative filtration, we have typically we'll see sort of a user-oriented collaborative filtering or an item-oriented collaborative filtering. Item-oriented is pretty simple. So if we kind of imagine this graphic right here, the idea behind an item-to-item collaborative filter is that, if it just so happens that both of these respondents are using Figma for mockups, and we need a recommendation for concept testing, it just so happens that somebody who was using Figma also used Google Workspace, and we were interested in concept testing. Cool. Right.
Pete, I think you could be a UX designer or researcher because of the way about deep levels of of these use cases. But sorry to interrupt.
No, not at all. And really, we can thank my spouse for exposing me to this world. And if I'm honest, it's an interesting place. It's different from my usual day to day. So, but anyway, we have a typical item recommendation approach, and we see that quite a bit. The alternative, of course, is a user-based approach, and for our use case, that's where we find the approach to be the best, because we've been emphasizing so far that there may be specific characteristics about our respondents that really do more to define which tools they may be able or willing to use over others, right? Again, like the example of if you're based in Europe or your participants are in Europe, when you're collecting data about, your participants, you may be limited in scope in terms of what software you're able to use based on how well it complies with GDPR and privacy laws, right? So in that case, just because somebody else happened to use a popular tool that's really cool in North America doesn't mean that you can use it in Europe. So by virtue of focusing on a user-to-user based recommendation, what we're interested in are the demographics or characteristics of our respondents first and foremost. And if it just so happens that respondent number 2 is similar to respondent 1, then maybe because they're so similar, given those demographics, it's more likely that Google's Workspace is a more applicable tool for my needs for concept testing than if the recommendation came from who knows who else that was nothing like my team at all. So let's actually see what this looks like in reality. And to kind of throw things together here and set the stage, our primary resource that we are currently using for data collection management is Airtable. And all of this is hosted on the ReOps community website, which Damien was kind enough to post the links in the chat. So definitely feel free to check all that stuff out. The data are navigable there if you'd like to take a look at what the Airtable data looks like. Next, basically, I decided to use Python as my ETL for a couple of reasons. One, I'm a data scientist. Python is everywhere. It's kind of ubiquitous in that sense. So makes sense from an ease of use and comfort point of view. But it's also really nice in part because of how easy Neo4j's API is to use. And there's even more than one way to approach that, right? Because there's certainly the base Neo4j API, but then there's also the Graph Data Science API, which in the demo code, which there's a link for that here coming up shortly. But you'll see in the example code that we have that underlies today's demonstration that I use both, right? And I use both because why not? Like just to show that, hey, in one situation, maybe you need the functionality of the base and in others, well, you're going to be doing data science stuff. So might as well use the Graph Data Science API. And then finally,
Go
ahead.
I would say one thing I really appreciated about Pete's approach was not having too many tools. In this project, we had to be very deliberate on limiting how many things we were using, so we weren't context switching and bouncing around all the time. So I've appreciated how we've limited this to just 3.
Oh yeah, I mean, if there are 460 tools that have been recorded in the Toolbox Census in the UX world, why should we be adding too many more on top of that, right? So
yeah,
I'm totally. And then, yeah, since this is a Neo4j conference, no surprise, kind of the impetus to present today was the fact that I really wanted to see what we could do by translating the Toolbox Census into a graph form that makes it more intuitively navigable, especially from a visual point of view, but then also allows us to leverage the power of graph and being able to use things like index adjacency and all these other hot little perks and features that underlie a graph native approach, and make it easier to work with at scale, right, relative to traditional tables of rows and columns and stuff. Not to say that you can't build a recommender with rows, columns, traditional relational databases, but having everything in graph makes it so much easier because you can do everything in one place. No need for all kinds of complex joins and 1,000 relational tables and all the rest of that nonsense. We don't need that. We want something that's intuitive, that can be explained and visualized. So our objectives for the demonstration is I'm going to run through in like about 5-10 minutes or so, kind of give you a sense of what it looked like to import the Airtable data via that Python API. Not going to spend too much time on the code, but the link is there at the bottom. And Damien, if you have a chance, if you would be so kind as to paste the GitHub link if you haven't already, so folks can check that out at their leisure. And indeed, we use Python to kind of prep the in-graph data before we push it into the graph, and use the API to push it into the graph. Of course, we build the recommender system entirely within the graph. We can still do all that from Python, but everything is done using Cypher queries that are sent to our server and everything like this. Write the new relationships back to the graph, and then we can either again use that API to query the graph, which is pretty great considering Neo4j API. When you run queries, it outputs. It can output your results as a pandas data frame straight away, so not requiring any like transformation, fancy footwork there. And then we'll also kind of show how you can leverage additional tools that are supported by Neo4j, including NeoDash and then the Bloom Explore tool to allow your end users and stakeholders to explore your graph without necessarily having to know a lick of Cypher or Python or any other coding language for the purpose of exploration.
Let's see it already. Let's see
all
it.
All right. Okay, so all right, playing it up. So just to kind of give you a sense of the simplicity of how we're doing things here, and I'll zoom this in so that y'all can see it a little bit easier here. But to get everything from Airtable, really it's like with any API, you got to have your token. You have to know, in this case for Airtable, a base and a table ID. as well as information about which type of view, which that's specific to Airtable. But I wanted to make sure that I was only grabbing the prod table, so the cleanest, most ready-made data that's available, which is also viewable on the website. And yeah, just kind of bring in the data as one does. It doesn't take too much to convert the Airtable data into a Pandas data frame, and the instructions and tutorials on the Airtable API documentation are really good. So super easy stuff there. And then we're able to, get our Airtable data in the form of a data frame, right? And then after this, I start my data munging adventure, transforming the data into the right shapes. I do a bunch of stuff under the hood that I'm not going to go into, but it just kind of helps navigate what the data look like. And you'll kind of get a sense of that from some of the outputs that are in here. Once everything is in, and we want to get everything in the right shape. So actually, I do want to kind of really quick show, and in the code, you'll see I have a bunch of repeated blocks of code here. This is really easy to loop, obviously. So for our coding experts in the audience, right? I apologize for the cringe, but I did want to emphasize just what this looked like, and make explicit every single one of my steps. But in production, and for efficiency's sake, you can easily loop this either just straight up in a while loop, list comprehension, dictionaries, all the rest of it. Y'all know how to do that stuff. But I create reference tables that I'm going to use for both relationships and nodes that are going to get pushed to the graph. And that's pretty much what most graph engines will look like. So if you've ever had to use Teradata or Oracle's graph engine, you still need those node and relationship reference tables when you're working with that graph engine. And that's effectively what I did as well in this case. So that'll be nice for folks who are used to that. But alternatively, what I would say is, after we create those data frames in memory in Python, we don't ever have to use those reference tables ever again, because everything's going to be in the graph. So one little step to jump through, or one little hoop to jump through, but it is what it is. And so next, here in this notebook, first notebook, I was using Neo4j's base API, but here I'm using the graph database. This is still Neo4j actually. The next one I use the graph data science. But indeed, all I'm doing is I'm just running sessions in order to create indices and constraints. And then I start just creating all of my nodes and eventually my relationships, right? So you can see in this example here that the API is very easy to use. All you need to know is just what does your command look like in Cypher. So if you're used to uploading CSVs and then running things in the browser, this is effectively the same thing. It's just that we're doing it from Python, right? And we're just making references to our Pandas data frames that we've created already, right? And then we just push all that stuff into the graph, create our nodes, create our relationships, and we're done, right? So finally, once we actually get everything into the graph, then the last step is we run our graph data science API, because we're going to be doing some graph data science. And of course, there are different ways that we can, interact with the graph. So if I just kind of load these up really quick, make sure I'm connected appropriately, we'll run a given query, let's say, and it'll be really nice in terms of it being able to just output, a nice little data frame for us, right? So if I were to save this as an object, it would show up as a Pandas data frame. Right. And so we can do some exploration here and see like, oh, there are 461 tools, 205 respondents, neato bonito. We can get a list of tool names and how many use cases are being used, or under which use cases are they being used, and so on. But this is still like tabular, though. This is not graph. This is not visual. Wow. It's not intuitive.
Yeah,
right?
Pete, I'm getting too much anxiety here because I'm still seeing 400 things. I need a recommendation.
Yeah, so we're going to build that recommender now. And again, this is all very simple, right? So we can start up. So the first thing I do is I want to, get my data in the graph in the right place. I need some one-hot encodings for all of our categorical variables, go through all that stuff so that we can actually leverage those profiles for each of our variables that are demographics to weight how similar respondents are to one another. So, just kind of creating all these bits and bobs. And then, of course, you got to create a graph projection, which is really easy using the API. It looks very similar to what we can do natively in the browser. We can take a look at and see what that all looks like. And then finally, the recommendation system itself, one line of code, pretty easy. I use mostly default parameters for the sake of the demonstration, but there are lots of different ways that you can optimize and work with this. So really, I'm just looking at the default k equals 10 nearest neighbors, but we're leveraging all the information from these one hot encoded variables, and then we want to write a score property on a similar to relationship. That gets done, and so what I've also done is I've also mounted this same graph into an Aura database, because that's pretty cool, I think. And so we can query the graph directly and find out, oh, what tools are being used for research planning. And we'll see that, it turns out that, Asana, Figma, all these different tools, 47 are used for planning, right? Or we can see how many use cases is Figma for. Well, there's 25 different use cases. Doesn't answer your question, Andy, and that's what our recommendation is for. So if we know that we are looking for other respondents who use given tools for the same use cases, and we want to make sure that our pairs of respondents are similar to one another, right? And we know that our reference point for R1 is tech industry, startup, small corp, has folks in Canada, either participants or researchers, fairly small team, does user design research, and needs to see tools for planning and road mapping. And what this does is this gives us a nice table that I've made it really explicit in terms of what it shows, because we have what this does is really we're interested in this column here, this tool. And so as well as the use case. But I've added these extra things here so you can kind of see how well we happen to match up in terms of those demographics, right? And so this is effectively what the tool can do for us, is that we can make sure that our recommendation sources are applicable to our use case. So in some cases, we're all on the right discipline here, but we might not be all exactly in the same industry, right? But at the same time, though, if other things match up, then maybe it's still a useful recommendation, right? So we can take a look at that, but there's a better way. So how can we visualize this clearly and easily, intuitively? And that's where Neo4j's additional tools come in. And this will make you happy, Andy. So, yeah. Oh, did you have something to say, Andy? Sorry.
Oh, just saying we got like 2 minutes left, but yeah, hopefully.
Got it.
Yeah, I gotta say that Pete's also going to make this available to me, which is exciting, that I'll be able to explore the data because I can't code Python.
Mm-hmm. So what we have here is a lot of these demographics you can find, and these descriptive statistics you can find on the website. But in the event that, for your use case, you would like to just have everything in a one-stop shop area, then you can basically just put a Neodash, plop that right on top of your graph, and build these same kind of interactive charts where you can kind of explore and take a look at what's happening. If it's open to editing, you can see that everything is just based on a simple match and return query to provide us with the information that we need. So it's really easy to set up. They even have some super cool graphics in which we can explore, where do teams have participants? 27 teams have Canadian participants. 2 of them have Finnish. One of them is in Ukraine, wowee, right? Folks in China and so on, right? And then teams with researchers, well, we've got it all around the world as well. So there's lots of different ways to kind of explore, slice and dice the data. And really, as we get closer to what we want, right, we've got lots of use cases, lots of tools, and we can break that out into a graph, but that still doesn't tell me what makes the most sense for me. And so we saw that table result earlier, but if we pop into Aura and look at Bloom, and this is the last thing I'll leave you guys with, is I created a query that provides us with the exact same results as what we saw in the table, and I saved it as a Cypher query. And instead of having to read through a table and sift through all kinds of information that may or may not be relevant to us, we can use Bloom to explore things directly, right? So if let's say this is our reference point respondent, right, and we're interested in those research road mapping and planning tools and that sort of thing, well, let me make sure that this is actually someone who may be in the tech industry. So if I expand that, hey, look, they're in the tech industry. Neato, right? And I can see, oh, is this person actually a good match for me? Well, yes, because we can see they're also in the tech industry, right? And so then we can start to just use this to just right click, start to expand, explore, what responsibility one team might have over another, right? And, we can go hog wild, expand all, and really just kind of start to explore things. We can add some filters if all we really want to see in terms of industry is just tech, right? Boom. And so we want to dismiss single nodes and dismiss filtered elements, that kind of thing, right? Clean things up, and also just even format what we've got. So yeah, lots of opportunities. Oh, we're out of time. Okay. So
Yeah, that'll be what'll be great is next steps. Like the what's going to be great is we're going to be able to potentially integrate some of this functionality with the ReOps Community Toolbox website and
yep.
help more people explore the data, using some of these tools. One thing Pete's really excited about is potentially looking at, the archives of our Slack channel and, using large language models to, find that chat history and see if we can get more, colorful data around recommendations around these tools. One thing that I just want to do immediately is try to get Pete to pick some of the most 5 interesting, groupings of similar tools and give me a starter kit for really common set of people, startup, tech industry, boom, and that's a really common little stack of 5 tools that uses would be a really good starting point for someone who's trying to do honestly a big job of evaluating and sourcing tools. Pete, got to thank you for this. Really excited about what we made.
Yeah, awesome. And yeah, send any questions our way via LinkedIn or however. Yeah.